Hi, my name is Jeff Coronado from JCSE, and this is a session in Bridging the Gap. So let me see here. We're covering WR1-1, distinguishing between a truss and a rafter. All right, so how do you know? I should highlight these in yellow. That would make it easier. How do you know if a rafter is just a rafter or if it is part of a truss? Yeah, which actually is a question that kind of came up recently. So kind of a valid question, right? Um, yeah, kind of like that. How do you know if a rafter is just a rafter or if it is part of a truss? Keep in mind, we're talking about wood framing right now, right? So we're saying some of what we're saying is only going to apply if the framing that we're looking at is made of wood. How do you know if a rafter is just a rafter or if it is part of a ridge and tie system? Okay, valid questions. Um, what is a truss? Well, we actually have covered a truss um, in another Bridging the Gap session. But we've seen that a truss is a series of members. They are interconnected, and that may be the one of the important aspects to keep in mind, right? When we're thinking of a truss, the members are interconnected, and we've seen that they behave as a beam. Um, okay, so a truss behaves like a beam. It serves the function of a beam. In wood trusses, in wood trusses, um, think of a triangle or a series of triangles that are interconnected. So let me see. Yeah, let me see. So if you think of a truss conventionally, what would we think of? Maybe, something kind of like this. Actually, you know what? I'm going to do it this way. Maybe that and that, that. We're building a truss here, right? We are kind of building a truss. Simplistic truss, yes. Oh, you don't like that? You want to see this be pitched a little bit? Sure, we can do that. Let's see if I can do that. What if I do this? Let me start over here. We do this. So there's more of a pitched truss, right? The roof is pitching up. In reality, the top chord, and remember some of this terminology we've already covered in other Bridging the Gap sessions, but the top chord, bottom chord of a truss, we can take a lot of liberty in how we shape that, the profile that we want, right? So we don't have to be constrained to, for instance, something that's like a flat surface on the top. We don't have to be constrained to just a single pitch on one chord. The profile of the top chord and bottom chord, we can take great liberty with and still frame it with a truss. But the one thing that you might see that kind of repeats itself is this triangular shape, right? The triangular shape. What his history has taught us is a strong shape. So it's a series of triangles. It's a series of triangles. Now, keep in mind, again, we're talking about wood, right? Um, in steel, it doesn't quite, well, it does apply in general to steel, but there are configurations that don't have to be in a triangular shape. But for wood purposes, um, I think invariably we're going to see trusses that are made of wood are going to be really a series of triangles. Okay, so that's kind of what we have to keep in mind for trusses that are framed of wood. It's a triangle or a series of triangles that are interconnected. Okay, now let's go to the other kind of key thing that we have been talking about here, this ridge and tie system. All right, so what is a ridge and tie system? Let's see if I can clear this. You know what? Let me keep that. What is a ridge and tie system? All right, well, in a ridge and tie system, that's a very straightforward, a pretty straightforward, I should say, a pretty straightforward framing concept for a roof. Um, and this is, again, applicable to wood. All right. So in a ridge and tie system, highlight this so that I can kind of say we've covered this, because now let's talk about the elements of a ridge and tie system. So in a ridge and tie system, we have a rafter, okay, or we have really two rafters. So let me use blue. We've got a rafter, and obviously I'm just using stick diagrams here. We have a rafter here and a rafter here, right? So what we're not talking about is the wall, and the floor, right? Little section of a something that you would see very frequently in a home, right? Residential construction. We've got a rafter. We've got a rafter. What else? Rafters. We have a tie. We use a different color for the tie. We use green. Oops. Do that. We use green for the tie. So what is that tie, that light green member? What do you think that represents in practice? Well, real good chance that represents the ceiling joist, right? That's the ceiling framing. So what is simplistically looked at as just a ceiling member, a ceiling joist, has a more has another use purpose, I guess would be the word. Another purpose, serves another purpose, and a very important purpose. It is the tie, it is the tie of the ridge and tie system. Okay, so this member here is the tie in a ridge and tie system. So if we go back and continue to look, let's continue to look at the elements of a ridge and tie system. We've got the rafters, right? We've got two rafters, opposing rafters, one going up from one side, one going up from the other side, and they meet in the middle. We've got rafters. We've got a tie, the green element. We've got a ridge board. Okay, so the ridge board. Oh, I'm going to get stuck here. Let me see. Let me use yellow to illustrate the ridge board. The ridge board is even smaller than that. Typically a 1 by, okay? A 1 by or a 2 by. Um, so really it's a very small, very slender. It's not a wide member, okay? It's not a 4 by, not a 6 by. It's a 1 by or 2 by flimsy member um, that that is located between the rafters at the top, at the apex crown, the ridge, okay, whatever you want to call this. It's the 2 by or 1 by that's up here. Its purpose is pretty much just serves to kind of hold the rafters in place, because if this wasn't here, then the rafters would almost have to butt up into each other to be stable when this is first getting laid out, when it's first being built, right? So it's easy to just place the ridge board first, and then that way these rafters, no, let me change this to blue. These rafters can sequentially just be dropped in, right? Just boom, boom, because then they drop in and they butt into this ridge board. And then you can come in and lay this one, right? Boom, boom, just lay them in. Um, so that's the purpose of the ridge board. Doesn't really carry any loading, but it's just for practical purposes. But there is a ridge board present in a ridge and tie system. The next thing that's important are the connections. And by the connections, what we're looking at, what we need to focus on is the connections that are located at this juncture, at this meeting point between the rafter and the tie, and maybe even that supporting member, which in this case I've illustrated as a wall. But the connection. Yeah, let me get into this right now. So here is an important aspect of a truss, and as we're seeing, let me see, have we covered that? I think what we're seeing, well, we can cover it right now, is a ridge and tie system a truss? Is a ridge and tie system a truss? Right? So think about that for a second. Is this ridge and tie system that I've illustrated here, these two rafters with this horizontal member, this tie, is it a truss? Well, the answer is yes, right? It's a very simple truss. It's as simple as it gets, but it's a truss. We've got a triangular shape. Um, all three members are in the same plane. Um, what else? They're interconnected. It serves as a beam, right? Because this is kind of like the longitudinal direction with transverse loading, all the things that we've covered in the past that kind of constitute a truss is what we have here. So yes, a ridge and tie system is a simple truss made out of one triangle, a single triangle. Um, so in a truss, in a truss, uh, what do you think happens if we were to slice, let's say the bottom chord? If I come in here with my big scissors, and boom, can't even see that. How about here? Boom, cut that, right? If I cut the bottom chord, if I just slice it, does that create a problem? Yeah, absolutely, right? Absolutely. Um, that's going to cause this truss to fail. Likewise, if I cut this right here, okay, cut it right here, either way, right? If I cut the bottom chord of this truss, I'm going to cause it to fail, right? In this ridge and tie system, this what in essence is made out of the ceiling joist. If I go in here and I cut ceiling joists, I'm causing this truss to fail. This what's probably going to happen here is um, these walls are going to kind of bow out. The walls will bow out. This ridge will drop. Can't even see that. You know what? Let me use another color. I'll go back to, actually, I'll use white here, huh? I can use white. The ridge will drop, okay, and then the rafters will now kick out. They'll go from where the wall has displaced to bowing out after it bows out, and where the ridge has dropped down to. That'll be where the rafters will relocate to. Okay, but it manifests itself, the most obvious place probably is in the walls bowing out, and the ridge dropping. And if this happens enough, let's say if this happens to enough of the ceiling joists where they get sliced, this could cause a complete failure, right? Okay, so what is a ridge and tie system? I think we've covered that. The ridge and tie system is composed of rafters, tie ridge with connections. That's kind of where we left off, right? So going back to this connection, um, yeah, let me so if we focus on kind of the rafter here, the ceiling joist, and let's say the wall, right? So this is kind of looking at this juncture, right? That's what we're looking at over here. Um, we just saw that if we slice that ceiling joist, if we slice the tie, if we lose the tie, we lose the truss. Well, then that means that this connection right here is real important, right? Because if this tie is not connected, let's say if this tie is not connected to the rafter, then the tie can just pull out. And we've lost our ridge and tie system. We've lost our truss. So the connection between these two is real important. That's part of the ridge and tie system. Um, Indirectly, this connection can be made through the supporting member here. And we don't want to get too much into that because that is kind of covered in another bridging the gap session. But yeah, if you want to say, can you indirectly connect, let's say, the rafter into the supporting member? And for purposes of illustration, let's say that we've got a wall here, and the rafter connects into the wall, into the double top plate, and then the ceiling joist connects into the double top plate, and they're in close proximity. Can you make the load transfer that way? Yeah, you can probably justify that load transfer, right? So there's almost no direct connection between the rafter and the ceiling joist, but there is a load transfer from the rafter to the double top plate to the ceiling joist. And thereby you make your load transfer to make this connection. But somehow you have to make a strong connection between the rafter and the tie for the rafter, for the ridge and tie system to work. Okay. Um, let's see. Is a ridge and tie system a truss? We've covered that. Yes, right? The answer is yes. A ridge and tie system is a truss. If we slice the bottom chord, does that cause failure? Absolutely, right? If we slice the bottom chord of the truss, whether it's a, let's say, more conventional, more complicated truss, or whether it's a ridge and tie system, if we lose this, if we slice through this member or lose the connection, um, between the rafter, and the bottom chord, we'll have failure, right? That means the truss has failed. Okay, let me clear the screen and let me see about moving down here. So we have an example. In this example, are we looking at a truss? Are we looking at a ridge and tie system? All right, well, let's take a look at this. Are we looking at a truss? Well, the first thing that is pretty apparent is we have rafters here. Okay, there is a rafter. Can we agree on that? Right, we've got rafters. Um, and in fact, above the rafters, and I believe this is covered in another Bridging the Gap session, but you can even see here we've got skip sheathing, right? Which are these slats that go across above the rafters and perpendicular to the rafters. But notice how they're spaced, hence they're called skip. So that's why this is called skip sheathing. And above the skip sheathing, you have wood structural pattern, okay? Meaning this residence has been re-roofed. This would not have been part of the original construction. Okay, so we've got skip sheathing, we've got rafters. Um, I think where it starts to get interesting is see is with these members going across here, right? Um, These members, you could say they're diagonals, right? And that's one of the things that we've covered in another Bridging the Gap session. The webs in a truss are formed of diagonal or vertical members. Remember that from another Bridging the Gap session? So you could look at this and go, well, here are the diagonals. Do I have a truss, right? Is this a truss? So valid question for you. Is this a truss? I've got rafters, I've got the rafter. And if not a truss, is it a ridge and tie system? Okay, either way, right? I've got the rafter and I've got diagonals. Okay, so is this a truss? Let you ponder that for a second. So let's go back up. So one of the things that we had said is a truss is a series of members that are interconnected. Okay, interconnected. Let's go back and take a look. Are these vertical members connected to what is the top chord of this truss? And the answer is no, right? These vertical members, and you know what? Let me even do that, and let me see if I can zoom in a little bit, because I think if it should be clear, but if it isn't, if we zoom in a little bit, we can see that these vertical members here, I'm sorry, these diagonal members, this diagonal member is not connected to the rafter. This diagonal member is closer to us. Then there's this horizontal element here, and then we get to the rafter. Okay, so they are not in the same plane. Right? Maybe now we're getting a little fancy here, but they're not in the same plane. This diagonal member, what you might want to consider as a web, if you're considering that this might be a truss, this web member is not in the same plane. It is not connected to the rafter. Okay, so let's revisit this. Let's revisit our question. Where'd it go? Okay, are we looking at a truss or are we looking at a ridge and tie system? Well, the answer is no, right? No, they are not connected. These diagonal members are not connected to the rafters. This is not a ridge and tie system. And in fact, this is actually covered in another session of Bridging the Gap, because this is a strong back. So this horizontal member here is a strong back, goes all the way across. And these are called kickers. And actually, yeah, this is covered in another Bridging the Gap session, the concept of strongbacks and kickers. But no, because they are not connected, they are not in the same plane. These diagonals are not in the same plane as the rafters, and they are not connected to the rafters, then the answer is no. This is not a ridge and tie system. This is not a truss. Um, uh, I'm sorry. Actually, this is a ridge and tie system. This is a ridge and tie system. So I'm picking this back up. I think we left that, yeah, we left that establishing so we were talking about these diagonals, and do the diagonals, are they webs? Are they webs? Are they part of a truss? And I think we already established the answer was no, right? They're not part of a truss because they are not directly connected to the top chord. They are not even in the same plane as the top chords, right? So again, if each rafter is the top chord of a truss, right? Then for these webs, for these members to be the web of the truss, each one of these would need to be connected at the top here to the rafter, and they're not in the same plane, right? Um, and as we kind of said, there's actually another member here that, sorry, there's another member here that I'm going to take off the line, but right here where I'm showing you the green arrow, and let me remove this line, right? There's another member there, which is a strong back. So the answer is these diagonals are not they are not webs for this assembly. Uh, so then the question is, if we don't have a conventional truss, do we at least have a tie, a rafter tie system? Um, that gets a little bit, um, a little bit harder to discern, but let me clear the screen here and let me show you something. So we agree that we have a rafter, right? We have a rafter. What we can't exactly see is the connection at the bottom of the rafter, but we know we have a rafter. Now take a look at this member going across here. Okay, I'm going to remove that so that you can see it more clearly, but keep your eye on that area. Do you see that horizontal member? Right now I'll use an arrow. This horizontal member that's connecting one rafter, presumably, to another rafter, right? I think we can make that assumption since we kind of know that this is symmetrical, oops, I don't want to use an arrow for that. So it's symmetrical kind of about where the ridge occurs, the apex of the top of the rafter. So we can assume that this horizontal member connects to another rafter, but we've got a horizontal member. Okay, so does that constitute a web for a truss? No, right? I think we saw webs of trusses are either diagonals or vertical elements, but not horizontal members. This is actually a collar tie. And you know what? Let me write this down, put it right here. Because actually a collar tie is covered in another Bridging the Gap session, but that element there is a collar tie. And what a collar tie tells us is that, remember the sketch, and we already lost it, but let me see if I can recreate it here pretty quickly for you. If we have a rafter, um, and a tie going across, and a ridge board, we have a rafter tie system, right? We have a rafter tie system if we have a ridge board. This collar tie, this collar tie that we're seeing here is actually an element that goes across close to the top of the rafters. When we see collar ties like this, that tells us there's a ridge board. Okay. If there was a ridge beam instead of a ridge board at the top, then we wouldn't see the collar tie. If we have a collar tie, it's because we have a ridge board. And if we have a ridge board, then we have a ridge and tie system. So that's what we're looking at here. So yeah, let me clear the screen and kind of summarize this a little bit. Um, So we've got rafters here. Well, we can even back up here. We've got wood structural panel sheathing here, skip sheathing here, rafters, a collar tie here. And notice how the collar ties don't occur at every rafter. In fact, we can see at least one other collar tie here, and it's back here. So it looks like we're skipping two rafters maybe. So rafter with collar tie, no collar tie, no collar tie, and then the one behind that does have a collar tie. And that's pretty standard for construction for collar ties. Okay, so we have collar ties, rafters. We have a strong back here. We have kickers. What we can't see in this image is the tie, which would be underneath this insulation. This is blown in insulation. Underneath the insulation is the tie, or embedded in the insulation is the tie. So we have a ridge and tie system. Sorry, rafter and tie system. Ridge tie, what are we calling these? Let's see if I can go back into our guide here. A ridge and tie system, okay. So we do have a ridge and tie system. Um, these are not part of a truss. These diagonal members are not part of a truss. We do have a ridge and tie system. Collar ties are covered in another Bridging the Gap session, as well as the strong backs and kickers. But that's what we're looking at here. Okay, so that's it for this session of Bridging the Gap.